Hello students, first of all I welcome you all to my second video on the chapter alcohols, phenols and ethers, right? In the previous video we discussed something about the meaning of alcohols, classification of alcohols and of course nomenclature of alcohols, right? All these discussions that we had in the previous video, right? Now we'll continue that discussion on alcohols, right? That is the structure of alcohols. Next discussion is structure of alcohols. And that will be structure of alcohol. This is the next topic, yes. And in order to discuss the structure of alcohols, I refresh your mind with the structure of water. That is, look at this. This is water. Yes, you studied this in first PUC. This water has got two lone pairs on the oxygen, right? This is structure of water. Yes. We studied that the bond angle is 104.5 degree. Yes, 104.5 degree. That is structure of water in the case of water, and this oxygen is very essential, that is sp3 hybridized. Oxygen of water is sp3 hybridized, right? Look at this. This is one simple model. You can have it. This is simple model, right? Yellow color is sphere is oxygen to which two hydrogen atoms are attached, and this is it is water with a bond angle of 104.5 degree. Here the bond angle is how much? 104.5 degree, because even though oxygen is sp3 hybridized, bond angle decreased from 109 degree 28 minutes to it is 104.5 degree. You know this because lone pair repulsions will be greater than lone pair bond pair repulsions, right? Because of this, that is bond angle is decreased from 109 degree 28 minutes to it is 104.5 degree. You studied this in first PUC, right? Friends, in order to study the structure of alcohols, because alcohols can be obtained by replacing one hydrogen atom of water by it is alkyl group. Look at this. Simply replace one hydrogen atom of water by it is alkyl group, that is R group, that is R, it is OH, yes, and of course with the two lone pairs on the oxygen, right? And of course in the place of R I keep this is CH3, right? In the place of R I keep CH3. This is methyl group, right? This is what we call it as methyl alcohol. This is I take this reference in order to study the structure of alcohols, right? In the case of alcohols, here also oxygen is sp3 hybridized. Right? This carbon of the methyl group is also sp3 hybridized. Carbon of the alcohols is also, that is carbon attached to oxygen is also sp3 hybridized. Therefore, this C2O bond in alcohols is formed by the overlapping of it is half-filled sp3 hybrid orbitals. This is a sigma bond produced by overlapping of sp3 hybrid orbital of carbon and sp3 hybrid orbital of oxygen. That's right. And of course, as far as OH bond is concerned, look at this. This is OH bond. Yes. In the case of oxygen, we have, that is, in the case of alcohols, we have OH bond, right? This OH bond is produced by overlapping of sp3 hybridized orbital of oxygen and s orbital of hydrogen. This OH bond is produced by overlapping of sp3 hybridized orbital of it is oxygen and s orbital of hydrogen, and that is sp3s sigma bond. This is also sigma bond and this is also sigma bond, right? And of course, as far as bond angle in the case of methanol is concerned, it is 108.9 degree. 108.9 degree. Now we expected, look at this here, there is a slight increase in the bond angle from 104.5 degree to 108.9 degree, but still it is less than, bond angle is less than 109 degree 28 minutes, right? Bond angle is still less than 109 degree 28 minutes, that is 108.9 degree is less than 109 degree 28 minutes. So but this bond angle, yes, in the case of it is alcohols is greater than that in the case of water, 104.5 degree, right? Now this bond angle idella water ಗಿನ್ನ ಜಾಸ್ತಿ ಇದೆ, ಹಾಗಾದ್ರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ sp3 hybridized bond angle ಗಿನ್ನ ಕಡಿಮೆ ಇದೆ. ಯಾಕೆ ಅಂದ್ರೆ look at this, in the case of water, this is bond angle is 104.5 degree, ಹೌದಾ? ಈ bond angle is to 104.5 degree, ಹೌದಾ? Now one hydrogen is replaced by a methyl group which is bulky, right? One hydrogen is replaced by it is methyl group. Look at this, I replaced, yes, this hydrogen by methyl group. This is bulky group, right? Because of this bulkiness, there is a repulsion, and now this methyl group is bulky, occupies more space, and therefore bond angle increases. Bond angle increases from 104.5 degree to 108.9 degree. Okay na? ಈಗ ನೋಡಿ ಇದೇ ಒಂದು ವಾಟರ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದೆ, ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದೆ, ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಇದೆ. ಹೌದಾ? Two hydrogen atoms are very small. Yes. If this hydrogen is replaced by bulky methyl group, ಏನಾಗುತ್ತೆ? Bond angle increases, right? Bond angle increases because of this is bulky group, occupies more space. Because of that steric hindrance between CH3 group and hydrogen, bond angle increases. Therefore, bond angle increases from 104.5 degree to 108.9 degree. That is what we call it as, yes, it is structure of alcohols. Agboda? So competitive exams alli idr ಬಗ್ಗೆ ನೀವು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು. Look at this. This is what we call it as structure of, yes, it is methanol. ನೋಡಿ ಇದು methyl group. Yes, CH3. This is O. This is H. Okay na? This is CH3OH. ಕಾಣುತ್ತಲ್ಲ? Yes. Okay na? This is what we call it as methyl alcohol. Bond angle is 108.9 degree. This is what we call it as structure of alcohols. Now with that information, then I'll go for the ethers, right? Look at the preparation of alcohols, right? Preparation of alcohols. As far as your NCERT syllabus is concerned, right? Preparation of alcohols. As far as our syllabus is concerned now, right? NCERT textbook is concerned. We are supposed to study preparation of alcohols from alkenes. Preparation of alcohols from alkenes. Then preparation of alcohols from carbonyl compounds, aldehydes and ketones, right? Preparation of alcohols from carboxylic acids. Okay na? And of course, then finally it is preparation of alcohols from, yes, it is Grignard reagents. Preparation of alcohols from Grignard reagents. These are the discussions that we are supposed to discuss under the preparation of alcohols, right? Okay na? Now at this moment, we'll begin with preparation from alkenes, right? That is, alkenes are characterized by double bonds, carbon to carbon double bonds. I'll start with the simplest alkene, that is CH2 double bond CH2, right? This is simplest possible alkene, right? And I'll go for one more alkene, that is CH3 CH double bond CH2. This is also alkene. Both are characterized by double bonds, right? And it is ethene, and this is ethene, and this will be propane, right? This will be propane. Yes. If this ethene undergoes, yes it is. Yes it is. If this ethene undergoes acid catalyzed hydration, that is acid catalyzed hydration, right? In presence of H plus ion, that is acid medium. If ethene undergoes acid catalyzed hydration, addition of water across the double bond. Hydration is addition of water across the double bond, right? That is as far as water is concerned. Look at this. This is water, yes. And depending upon the difference in the electronegativities, hydrogen will be positively charged, and of course oxygen will be negatively charged, right? Hydrogen will be positively charged, oxygen is negatively charged, and of course water can give hydrogen in the form of H plus, and of course you are going to get OH in the form of OH minus, right? And of course here, and in presence of H plus ions, right, pi electrons will be shifted over any one of the carbon atoms, right? Pi electrons will be shifted over any one of the carbon atoms. This is symmetrical alkene. Adu gamana irbeku. This is symmetrical alkene, yes, because on either side of the double bond, same groups are there. LeCH2 ide, LuCH2 ide, right? In the case of symmetrical alkenes, pi electrons will be shifted over any one of the carbon atoms. ಈ ಕಡೆ ಏನಾದರೂ ಶಿಫ್ಟ್ ಆಗ್ಬೋದು, ಈ ಕಡೆ ಏನಾದರೂ ಶಿಫ್ಟ್ ಆಗ್ಬೋದು. ಈಗ ನೋಡಿ, ನಾನು ಹೇಳ್ತಾ ಇದ್ದೆ, if I shift electrons like this, right, head will get negative, tail get positive ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೆ. If I shift electrons like this, head will get negative, tail will get positive, right? ಈಗ ನೋಡಿ, the negative part is attacked by positive part of water, yes. Positive part of this molecule is attacked by negative part of water, yes. Therefore, OH minus attacks this, H plus attacks this, right? ಅಥವಾ ನೀವು ಹೀಗೆ ಶಿಫ್ಟ್ ಮಾಡ್ಬೋದು, ಏನು ತೊಂದರೆ ಇಲ್ಲ, right? You can shift like this also, right? You can shift like this also, because on either side we have same type of groups, right? Therefore, if I shift like this, this will get negative charge, this will get positive charge. Therefore, this positively charged carbon is attacked by OH minus, and this positively charged hydrogen attacks negative, that is CH2 minus. Then you are going to get what we call it as one of the product, that is CH3, H plus CH3 double bond is converted to single bond, that is addition reaction, that is CH3 single bond CH2, then OH minus will be connected to this, and it is what we call it as ethanol. This is what we call it as ethanol, right? So this is one example for the preparation of alcohols from alkenes. ನೋಡಿ ಯಾವುದೇ ಆರ್ಗ್ಯಾನಿಕ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನು ಸ್ವಲ್ಪ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ನಾನು ಹೇಳ್ತಾ ಇದ್ದೇನೆ ಅಂದರೆ ಸಬ್ಸ್ಟ್ರೇಟ್ ಅಲ್ಲಿ ಪ್ಲಸ್ ಮೈನಸ್ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು, ರಿಯೇಜೆಂಟ್ ಅಲ್ಲಿ ಪ್ಲಸ್ ಮೈನಸ್ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು. ನಿಮಗೆ ಗೊತ್ತಿದೆ ದಿಸ್ ಅ ನ್ಯಾಚುರಲ್ ಟ್ರೂತ್. ಏನಪ್ಪಾ ಅಂದ್ರೆ ಪ್ಲಸ್ ಆಲ್ವೇಸ್ ಅಟ್ಯಾಕ್ಸ್ ಮೈನಸ್. ಹಾಗಾಗಿ ಇಲ್ಲಿ H ಪ್ಲಸ್ ಇದೆ, ಇಲ್ಲಿ ಮೈನಸ್ ಇದೆ, OH ಮೈನಸ್ ಇದೆ. ಹಾಗಾಗಿ OH ಮೈನಸ್ ಅಟ್ಯಾಕ್ಸ್ CH2 ಪ್ಲಸ್, H ಪ್ಲಸ್ ಅಟ್ಯಾಕ್ಸ್ CH2 ಮೈನಸ್. ನಾನು ಶಿಫ್ಟ್ ಮಾಡೋದು ನೋಡಿ, ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಎಸ್ ಇಟ್ ಇಸ್ ಮೈನಸ್ ಆಗುತ್ತೆ, ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಇದು ಮೈನಸ್ ಆಗುತ್ತೆ. ನೀವು ಆ ಕಡೆ ಆದ್ರೂ ಮಾಡಬಹುದು ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಸಿಮೆಟ್ರಿಕಲ್ alkene and you are going to get ethanol. Yes, ಆಗ್ಬೋದಾ? This is what we call addition of water across the CH2 double bond CH2, that is ethene. Yes, we go for the one more example, and this is propene. If I add water across the, yes it is propene, this propene is unsymmetrical alkene. Idilli bala careful agirಬೇಕು, unsymmetrical alkene. Yes, and of course here it is as far as right, okay na, right, propene is concerned, when water is added across the unsymmetrical alkene, when water is added across the unsymmetrical alkene, you need to follow one rule, what we call it as Markovnikov's rule. You need to follow Markovnikov's rule, right? You need to follow Markovnikov's rule, right? You need to follow Markovnikov's rule, right? According to Markovnikov's rule, during addition of unsymmetrical reagent, this is unsymmetrical reagent because here H is there, here OH is there, unsymmetrical reagent to the unsymmetrical alkene. Why it is unsymmetrical alkene? Across the double bond, here CH2 is there, here CH3 CH is there, therefore it is unsymmetrical. The negative part of the adding molecule will be attached to that carbon atom of double bond containing least number of hydrogens. Negative part of the adding molecule will be attached to that carbon atom of double bond containing least number of hydrogens. That according to Markovnikov's rule. ಹಾಗಾಗಿ OH minus ಇಲ್ಲಿ ಬಂತು ಅಂದ್ರೆ right, this will be shifted over like this, right? CH2 minus attracts H plus. ಆಗೇನಾಗುತ್ತೆ ನೋಡಿ, this is CH3, right? Double bonds, that is single bond. Yes, ಈ CH ಯಾರು ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ OH, and of course CH, and it will be connected with OH, right? Then it is CH2, and of course H will be attached to this, then CH2 becomes CH3, right? ಈ H ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ, OH minus ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ. ನೋಡಿ ನಾವು ಆಡ್ ಮಾಡ್ತಿರೋದು, we are adding molecules across the double bonded carbon atoms. We don't disturb this double bonded carbon ಗೆ ಅಟ್ಯಾಚ್ ಮಾಡ್ತಿದ್ದೀವಿ ವಾಟರ್ ನ. ಒಂದು OH minus ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ, H plus ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ, ಆಗ double bond is converted to single bond. This is an example for addition reaction, that is electrophilic addition reaction, because this is initiated by the electrophile H plus, and of course reaction is carried out in presence of H plus, right? So this is what we call it as addition of water across the double bond according to Markovnikov's rule. And of course this is propane to all, and this is propane to all. Yes, and of course as far as preparation from alkenes is concerned, this method, this is direct addition of water, that is direct addition of water. Direct addition of water, that is here we added water across the double bond directly in presence of acid medium, because we are going to study one more, that is indirect addition of water ಅಂತ ಇನ್ನೊಂದು ಬರ್ತದೆ. ಅದಕ್ಕೋಸ್ಕರ ಈ ಪಾಯಿಂಟ್ ಅನ್ನು ಹೈಲೈಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಓಕೆನಾ? So this is what we call it as preparation of alcohols from alkenes by direct addition of water, that is hydration of alkenes. This can also be given a title, hydration of alkenes. So preparation from alkenes. ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ಸಿಮೆಟ್ರಿಕಲ್ ಇದ್ದಾಗ, ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್ ಇದ್ದಾಗ Markovnikov's rule ಪ್ರಶ್ನೆನೇ ಬರಲ್ಲ. ಅದೇ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್ ಇದ್ದಾಗ you need to follow that Markovnikov's rule. According to Markovnikov's rule, the negative part of the adding molecule will be attached to that carbon atom of double bond containing least number of hydrogen atoms, and accordingly you are going to get propane to all. You know the reason for that, because this is propane produces secondary carbocation that is more stable than primary carbocation. Because of that, addition takes place like this. You studied that in first PUC. So this is what we call it as preparation from alkenes, and that is by direct hydration, so direct addition of water. Yes, double bond. Yes, now let us see mechanism of it is mechanism of acid catalyzed hydration of acid catalyzed hydration of alkene to alcohol. This is mechanism of acid catalyzed hydration of, yes, it is alkene to alcohol. Yes, I'll just explain this particular mechanism by taking ethene as an example, right? As far as step 1 is concerned, right, you know, mechanisms, they are the detailed description of a chemical reaction. Okay, na? It gives all the information about the different steps involved in a chemical reaction, type of reagents involved in a chemical reaction, type of intermediate formed during a chemical reactions. In this particular, yes, it is a mechanism, right? First is what we call it as, yes, it is protonation of water. Yes, it is alkene. First step is protonation of alkene. That is protonation of alkene. Yes, I'll go for this. You know, as far as water is concerned, right? This is water in acid medium. It will be in the form of H3O plus, and it is hydronium ion. Hydronium ion. Of course, hydronium ion will be like this, right? This is hydronium ion, right? And this is what we call it as positive charge is there. Yes, this is hydronium ion, right? Okay, na? And that hydronium ion, yes, it is attacks, yes, it is alkene, right? And that is CH2 double bond CH2, right? Plus, yes, it is H. O, yes, it is H, and it is hydronium ion, and it is plus. Oxygen carries positive charge, right? Yes, okay, na? And this is what we call it as hydronium ion, right? Because of the presence of positive charge on the oxygen, right? Okay, na? And oxygen is itself electronegative. Oxygen itself is highly electronegative, and at the same time, positive charge is there. Therefore, it strongly attracts electrons towards it, right? It strongly attracts electrons towards it. Again, OH bond becomes weak and releases hydrogen easily in the form of H plus. Ella sigma electrons attract madkondaga OH bond weak agutte, aga it readily releases hydrogen in the form of H plus. And of course, as far as alkene is concerned, right? Okay, na? In presence of this hydronium ion, pi electrons will be shifted over any one of the carbon atom because it is symmetrical alkene, right? Because it is symmetrical alkene. Yes. Okay, na? Again, this will get negative charge, this will get positive charge. As usual, head gets negative charge, tail gets positive charge. Again, the minus alva attacks H plus. Hydrogen, I am removing hydrogen without bond. These sigma electrons oxygen hydrogen is released in the form of H plus. H plus will be attacking CS2 minus. Again, and you are going to get, yes, it is right. CS2 minus becomes what? CS3. H plus will get CS3. Double bond is converted to single bond. As we have shifted electrons over here, yes, CS2 becomes CH2 plus. CS2 becomes CS2 plus, right? You are going to get CS2 plus. You write positive charge on the carbon there, CS2 plus, right? Okay, you are going to get carbocation, and this sigma electrons will neutralize positive charge on the oxygen, and you are going to get H2O. ಇಲ್ಲಿ sigma electrons positive charge and neutralize ಮಾಡಿಬಿಟ್ಟು plus minus ಸೇರಿಬಿಟ್ಟು 0 ಆಗುತ್ತೆ. You will have with H2O. This is first step, that is protonation of alkenes, and you are going to get carbocation is an intermediate. You are going to get carbocation as an intermediate. Yes, this is first step, right? That is the second step, right? That is what we call it as attack of water, and that is attack of water. This is second step of the mechanism, right? This is attack of water, right? In the attack of water, now look at this. Which will attack that is? That is going to attack. That is CS3 and of course CS2 plus. The product of the first step. The product of the first step is the reactant of the second step, right? It will be attacked by, yes, it is water. It will be attacked by water, yes. And this is water. I can write like this, right? Water na heat baribodu nanu. Yes. Yes, water carries lone pair of electrons, right? So oxygen ಮೇಲೆ lone pair of electrons ಇದ್ರೆ minus attacks plus ಯಾವ್ದನ್ನ CS2 plus ಅನ್ನು ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ. electrons ಇಲ್ಲಿ ಕೊಡೋದ್ರಿಂದ oxygen has lost electron and gets positive charge, right? And like look at this, you are going to get one more intermediate of this type, CS3 and of course CS2. ಈ electrons ಇಲ್ಲಿ ಕೊಡೋದ್ರಿಂದ carbon is attached to oxygen, right? Carbon is attached to oxygen, right? ಆಗ ಇಲ್ಲಿ H ಇದೆ ನೋಡಿ, this is H and this is H, right? ಆಗ ನೋಡಿ, as it has given electrons to this, oxygen lost electrons and it gets positive charge. And this is what we call it as second step. And of course that intermediate is unstable. In the third step, yes, it is in step 3. Okay, now there is loss of proton. That is loss of proton, right? Step 3 is loss of proton. Yes, in the step 3, the product of the step 2 is a reactant of the step 3. Yes, ಅವೆಲ್ಲ ಸ್ವಲ್ಪ ಗಮನಿಸಬೇಕು ನೀವು. ಅದನ್ನು ತಪ್ಪು ಬರೀತಿರ್ತೀರ ಬಯಾಟ್ ಮಾಡಿಬಿಟ್ಟು. ಇಲ್ಲಿರೋದು ಪ್ರಾಡಕ್ಟ್ ಇಲ್ಲಿರ್ತದೆ, ಇಲ್ಲಿರೋದು ಪ್ರಾಡಕ್ಟ್ ಇಲ್ಲಿರ್ತದೆ, ಹೌದಾ? ಈಗ ನೋಡಿ ದಿಸ್ ಇಸ್ ದಿ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದಿ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಇಸ್ ಅ ರಿಯಾಕ್ಟೆಂಟ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್. ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಅಂದ್ರೆ H plus will be lost. ಪ್ರೋಟಾನ್ ಅಂದ್ರೆ H plus, ಲಾಸ್ ಆಫ್ ಪ್ರೋಟಾನ್. ಎಸ್, ಈಗ ನೋಡಿ ಯಾಕೆ ಲಾಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಏನ್ ಮಾಡುತ್ತೆ, ಸಿಗ್ಮಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ತನ್ನ ಕಡೆ ಅಟ್ರಾಕ್ಟ್ ಮಾಡುತ್ತೆ. ಆಗ H plus ಏನಾಗುತ್ತೆ, ಹೊರಗೆ ಹೋಗುತ್ತೆ. That will be taking place in presence of water. ಆ ಕೆಲಸ ಆಗೋದು ವಾಟರ್ ಸಪೋರ್ಟ್ ಇಂದ. ಆ ಕೆಲಸ ಯಾರಿಂದ ಆಗುತ್ತೆ, ವಾಟರ್ ಸಪೋರ್ಟ್ ಮಾಡುತ್ತೆ. ಓಕೆನಾ? ಆಗ H plus ಅನ್ನ ವಾಟರ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, H3O plus ಆಗುತ್ತೆ. H plus ಅನ್ನ ವಾಟರ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, H3O plus ಆಗುತ್ತೆ. ಈಗ ಈ ಸಿಗ್ಮಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡ್ಬಿಟ್ಟು ಏನು ಉಳಿತದೆ ನೋಡಿ, ದಟ್ ಈಸ್ CH3 CH2. ಎಸ್ ಇಟ್ ಇಸ್. ಆಮೇಲೆ OH H plus ಇಲ್ಲಿಗೆ ಬಂದಿದೆ. ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನು ಈ ನೆಗೆಟಿವ್ ಈ ಸಿಗ್ಮಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಿದೆ. And it is OH there, and it is what we call it as ethanol. That is what we call it as ethanol. So these are the 3 important steps that you come across in the case of, yes, it is mechanism of addition of water across the double bond, ಅಥವಾ acid catalyzed hydration of alkene to alcohol, ಅಥವಾ you can go for it ethene to ethanol ಆಗ್ಬೋದು, ಈಗೂ ಆಗ್ಬೋದು. Ethene to ethanol. So this is very important for the examination point of view. So this is one mechanism that you are supposed to learn. Yes, it is under preparation of alcohols, right? And remember, this is what we call it as direct addition of water across the double bond. That is hydration of alkenes, right? Hydration of alkenes, right? Fine. Now let us see. Yes, it is the reaction that is under the preparation from alkenes, that is B. This is also preparation of alcohols from alkenes, that is hydroboration. Hydroboration oxidation reaction. And this is also very important for the competitive exams. In last year CET you might be seeing one question on this particular discussion, hydroboration oxidation reaction. I'll go for this is HBO reaction. You can go for this abbreviation as HBO reaction, hydroboration oxidation reaction. And this is indirect addition of water. Indirect addition of water. Indirect addition of water to alkenes. Look at the reaction first and go for the details then. First reaction ನೋಡೋಣ, ಆಮೇಲೆ details ನೋಡೋಣ, right? Hydroboration oxidation, because there are 2 reactions here. One oxidation, first addition ಆಗುತ್ತೆ, ನಂತರ oxidation ಆಗುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರ, right? And of course as far as this reaction is concerned, right? In this reaction we'll take alkene like yes, it is propene. This is one of the alkenes, what we call it as propane. And this is propene. You just have that habit of writing names of the reactants, okay na, in each equation, right? In each chemical equation. That habit you should have. That is propene. So in presence of, yes, it is diborane. And in presence of diborane, right? BH3. And of course here diborane is actually in the form of, yes, it is BH3 is actually in the form of diborane, that is BH3 twice. In the reaction only BH3 part will take part in reaction. That's why BH3 ನಾನು reaction ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದೀನಿ, right? And of course this is what we call diborane B2H6, as you studied one of the hydrides of boron in first PUC. One of the hydrides of boron B2H6, that can be, yes, it is studied written as BH3 twice. As usual, boron hydrides are electron deficient. You know that boron hydrides are electron deficient. Yes. ಈಗ ಬನ್ನಿ first equation ಬರೀತೀನಿ, ಆ ನಂತರ ಅದರ explanation ಮಾಡ್ತೀನಿ, right? When propene reacts with boron hydride, okay na, all the 3 hydrogen atoms are replaced by 3 CS3 CS2 CS2. That is, you are going to get, yes, it is boron, yes, and that is CH2, right? CH2, right? And that is CS3, right? And this is 3 times, that is trialkyl borane. ನಿಮ್ಗೆ ಏನು ಸಿಗುತ್ತೆ ಫಸ್ಟ್ trialkyl borane. First, all the 3 hydrogen atoms are replaced by ನೋಡಿ CS3 CH CS2 ಇದೆ ಹೌದಾ ಬಟ್ ಇಲ್ಲಿಂದ 3 ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಏನು ಬರ್ತದೆ ಈ CH ಗೆ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ಒಂದೊಂದು ಮಾಲಿಕ್ಯೂಲ್ ಗೆ ಒಂದೊಂದು ಹೈಡ್ರೋಜನ್ ಕನೆಕ್ಟ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ CS3 CS2 CS2 ಒಟ್ಟು 3 ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ 3 ಮಾಲಿಕ್ಯೂಲ್ ಗೆ ಕನೆಕ್ಟ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ CS2 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 right CS2 CS2 CS3 that is 3 propyl groups attached to the yes it is boron that is trialkyl borane ಅಥವಾ tripropyl borane it can be tripropyl borane ಅಂತಾನೂ ಕರೀಬಹುದು yes then this particular yes it is tripropyl borane when it reacts with when it is oxidized using hydrogen peroxide when it is oxidized using hydrogen peroxide yes when it is oxidizing using hydrogen peroxide 3 molecules of hydrogen peroxide will be consumed and in presence of aqueous sodium hydroxide OH minus followed by hydrolysis right okay ಏನಾಗುತ್ತೆ look at this actually ಏನಾಗುತ್ತೆ ಅಂತ ನೋಡಿ B CH2 CH3 ಅಲ್ವಾ ಈ ರೀತಿ ಇದಲ್ಲ ಈ ಬಾಂಡ್ಸ್ ಎಲ್ಲ 3 ಬಾಂಡ್ಸ್ ಬ್ರೇಕ್ ಆಗಿ ಒಂದು OH ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ಒಂದು OH ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ because H2O2 ಇದೆಯಲ್ಲ ಅಲ್ಲಿ how do you write that this H2O2 this is HOOH ಬ್ರೇಕ್ ಆಗಿಬಿಟ್ಟು yes it is ಒಂದು OH ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ಇನ್ನೊಂದು OH ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ and of course you are going to get yes it is CH3 CH2 yes it is CS2OH 3 molecules 3 OH groups ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ರೈಟ್ ಇದರಿಂದ ಅವಾಗ ಏನಾಗುತ್ತೆ CS3 CS2 CS2OH yes it is propanol and remaining 3 OH groups will be connected to boron and it is BOH thrice okay now that is this is called as boric acid and of course this is propanol this is what we call it as propanol yes and of course what is the importance of this reaction look at the very very important reaction because your addition of water takes place indirectly addition of water across the double bond takes place indirectly ಯಾಕೆಂದ್ರೆ ನೋಡಿ ನಾನು propene ತಗೊಂಡಾಗ look at this okay na ಈಗ ನೋಡಿ water I added water in presence of H plus right again ಗೊತ್ತಾ you got this CS3 CH OH and it is CH you got this your OH group is connected to CH H is connected to CS2 and it is according to Markovnikov's rule this is according to Markovnikov's rule right this is direct addition this is direct addition in the case of indirect addition look at this what I discussed now right this is indirect addition again I will product nodi your OH is attached to CH but here OH is attached to CH2 that is look at this first carbon nodi ಇಲ್ಲಿ OH is attached to second carbon your OH is attached to yes it is first carbon this is not according to yes it is Markovnikov's rule this is not according to Markovnikov's rule but it is according to Markovnikov's rule direct addition is according to Markovnikov's rule but indirect addition is not according to Markovnikov's rule that is anti-Markovnikov's product what is this it is anti-Markovnikov's product that here OH group is connected to double bonded carbon with least number of hydrogens howda but ಇಲ್ಲಿ OH group is connected to double bonded carbon with more number of hydrogens howda so this is not according to Markovnikov's rule but it is according to Markovnikov's rule that point has to be noticed ಹಾಗಾಗಿ whenever hydroboration oxidation reaction is carried out the product is not according to Markovnikov's rule but you are going to get anti-Markovnikov's product you are going to get anti-Markovnikov's product and that is what we call it as yes it is importance of this reaction you can bring about yes it is the addition of water across the double bond indirectly so that you are going to get yes it is the anti-Markovnikov's product and 1 propanol usual hydration ಮಾಡಿದ್ರೆ 2 propanol ಬರುತ್ತೆ indirect hydration ಮಾಡಿದ್ರೆ by using diborane and hydrogen peroxide followed by hydrolysis with excess water in presence of base and of course this is not according to Markovnikov's rule so this is what we call it as hydroboration oxidation reaction ನಾನೀಗ ನೀವು ಏನಾದರೂ ಎಕ್ಸಾಂಪಲ್ ಕೇಳಿದ್ರೆ ಸರ್ ನಾನು ಕೇಳಿದ್ರೆ ಇಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು ಅನ್ಸುತ್ತೆ for 2 marks you know so how do you convert propane to propanol ಅಂದ್ರೆ when propane reacts with diborane okay na in followed by oxidation with hydrogen peroxide in presence of sodium hydroxide, 1 propanol is obtained. This is propanol or 1 propanol is obtained. Yes. And ಈ ಈಕ್ವೇಷನ್ ಇಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು. ಯಾಕಂದ್ರೆ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ತುಂಬಾ ಸ್ಟೆಪ್ಸ್ ಇದೆ. ಓಕೆನಾ, 2 ಮಾರ್ಕ್ಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇದಿಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು ಅನ್ಸುತ್ತೆ, ರೈಟ್? ಓಕೆನಾ, ಆದ್ರೆ ಇದು ಕರೆಕ್ಟ್ ಆಗಿ ಈ ರಿಯಾಕ್ಷನ್ ಹೇಗಾಗುತ್ತೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು ಅಂದ್ರೆ ಈ ರಿಯಾಕ್ಷನ್ ಹೇಗಾಗುತ್ತೆ ಟ್ರೈಪ್ರೊಪೈಲ್. This is tripropyl. Yes, it is borane. This is tripropyl borane. Yes. ಈ ಕರೆಕ್ಟ್ ಆಗಿ ರಿಯಾಕ್ಷನ್ ಹೇಗೆ ನಡೀತದೆ ಅಂತ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬೇಕಂದ್ರೆ ನಾನು ಸ್ಟೆಪ್ ವೈಸ್ ಸ್ಟೆಪ್ ಬರೆದು ತೋರಿಸ್ತೀನಿ ನಿಮಗೆ. ಯಾಕಂದ್ರೆ ನಿಮ್ಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಕಷ್ಟನೇ, ಇದು ಸುಮ್ಮನೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಲಿಕ್ಕೆ, ಬಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಹೇಗೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಿಮಗೆ ತೋರಿಸ್ತೀನಿ ಈಗ. ಓದಿಸಿದ. ಎಸ್. ಸೊ ದಟ್ ಈಸ್ ಇಟ್ ಈಸ್ hydroboration oxidation reaction. Yes, go for it. Right, we have this, right? That is CH3, right? CH double bond CH2, right? Naturally that reacts with borane, and that is BH3 in presence of B2H6, right? B2H6. Actually BH3 exists in the form of B2H6, but in the reaction this will take part in reaction. Okay na? ಈಗ ನೋಡಿ, boron hydride ಇದೆಯಲ್ಲ ಇದು, and boron is electron deficient, and of course it is attached with 3 hydrogen atoms. Okay na? When in presence of boron hydride, electron deficient boron hydride, 5 electrons will be shifted over this, and of course it will be shifted over this only because that results in secondary carbocation. ಆಗೇನಾಗುತ್ತೆ, this H minus will be attached to this H minus. ನೋಡಿ ನಾನು ಹೈಡ್ರೋಜನ್ ಹೇಗೆ ತೆಗಿತಾ ಇದ್ದೀನಿ, ಹೈಡ್ರೈಡ್ ಅಂದ್ರೇನು H minus. I am removing hydrogen along with the bond. H minus will be attached to this because ಈಗ ನೋಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಇದು ಪ್ಲಸ್ ಇದು ಮೈನಸ್, ಮೈನಸ್ ಅಟ್ಯಾಕ್ಸ್ ಪ್ಲಸ್. ಅವಾಗ ಈ ಪ್ಲಸ್ ಏನು ಮಾಡುತ್ತೆ, ಈ ಮೈನಸ್ ಏನು ಮಾಡುತ್ತೆ, ಈ ಪ್ಲಸ್ ಅನ್ನು ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ. ಎಸ್, ಆಗ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ CH3. ನೋಡಿ ಏನಾಯ್ತು ಈಗ, this becomes CH2, right? And it is CH2. Yes, this will be attached to boron. Yes, and this is what we call it as, this is a product, propyl borane. This is, what is that? Propyl borane. Yes, ಈಗ ಬನ್ನಿ, and it further reacts. Now ಈಗೇನಾಯ್ತು, 1 hydrogen is replaced by CH3, CH2, CH2. ಹೌದಾ? We have still 2 more hydrogen atoms. They can also be replaced. Okay na? By in the form of H minus, right? ಈಗ ನೋಡಿ, CH3, CH double bond CH2. This is 1 more propene. Yes. ಹೇಗೆ ನಾವು H minus ಅಲ್ಲಿ ಇಲ್ಲಿ ರಿಮೂವ್ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ತರ ಮಾಡಿ. H minus will be attached to CH. Yes. Because 5 electrons will be shifted over to CH2. This will get plus, this will get minus. Minus attacks this, right? Okay na? ನೋಡಿ, ಕರೆಕ್ಟ್ ನೋಡಿ ನಾನು ಬರೆಯೋದನ್ನ. Plus minus plus is always attacked by minus. ಈಗ ನೋಡಿ, ಈ ಮೈನಸ್ ಈ ಪ್ಲಸ್ ಅನ್ನು ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ. ಹಾಗೇನಾಗುತ್ತೆ ನೋಡಿ, CH3, CH2, CH2. ಹೌದಾ? ಆಮೇಲೇನು, ಬೋರಾನ್. ಈಗ 1 ಹೈಡ್ರೋಜನ್ ಉಳಿದಿದೆ ಈಗ. ಎಸ್, ಈಗ ಏನಾಯ್ತು, this is connected to what? This is connected to what? Boron. What is that? CH2. CH2 is connected to this. H minus is connected to this. ಏನಾಯ್ತು ಈಗ, CH becomes CH2. And is as usual CH3, right? Okay na? Yes. Still we have one more. You know, hydride. Yes. That reacts with, right? That reacts with, yes. That reacts with CH3, CH double bond CH2, right? ಈಗ ನೋಡಿ, ಈ ಮೈನಸ್ ಏನು ಮಾಡುತ್ತೆ, ಇದನ್ನ ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ. ಎಸ್, ಅವಾಗ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ CH2 ಮೇಲೆ, ಪ್ಲಸ್ ಮೈನಸ್, minus attacks this plus, right? Okay na? Again ನೋಡಿ, you are going to get tripropyl borane. Yes, you are going to get, yes, that is what we call it as tripropyl. ಈಗ ನೋಡಿ, this CH3, CH2 boron, and it is CH2, CH3, and this is CH2, and it is CH3, right? Okay na? Yes. ಆಮೇಲೆ ಇನ್ನೇನಾಗುತ್ತೆ, oxidation of this product in presence of hydrogen peroxide, base OH minus followed by hydrolysis, base hydrolysis, right? ಆಗ ನೋಡಿ, ಈ ಬಾಂಡ್ಸ್ ಬೇಕಾಗುತ್ತೆ. ಎಷ್ಟಿದೆ ಬಾಂಡ್ಸ್ ಅಲ್ಲಿ? 3 ಬಾಂಡ್ಸ್ ಇದೆ, ರೈಟ್? ಈ ಕಡೆ ಒಂದು OH ಬರುತ್ತೆ, ಈ ಕಡೆ ಒಂದು OH, ಈ ಕಡೆ ಒಂದು OH, ಈ ಕಡೆ ಒಂದು. ಓಕೆನಾ? ಆಗೇನಾಗುತ್ತೆ, ಈ 3 molecules of OH ಇದೆಯಲ್ಲ, they are going to get 6 OH groups. So the 3H2O2 gives what? 6 OH groups. Out of 6 OH groups, 3 OH groups are connected to B, and it is BOH3, boric acid. Okay, now remaining 3 OH groups, 1 OH group to this, another OH group to this, one more OH group to this, therefore plus 3 times CH3, CH2, CH2OH, and this is what we call it as addition of indirect addition of water across the double bond. Indirect addition of water across the double bond, and that is what we call it as hydroboration oxidation reaction. ಇದು ನಿಮಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಮಾತ್ರ, ಇದೆಲ್ಲ ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಅರ್ಥ ಆಯ್ತಾ? ಆದ್ರೆ ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ನೀವು ಈಸಿಯಾಗಿ ಬರಿಬಹುದು ಅಂತ. ಯಾವುದೇ ರಿಯಾಕ್ಷನ್ಸ್ ಅಷ್ಟೇನೆ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ರಿಯಾಕ್ಷನ್ಸ್. ಆಗೇನಾಗುತ್ತೆ, ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಥಿಂಗ್ಸ್ ಈಸಿಲಿ, ಅದರ್ವೈಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮಗ್ ದ ಥಿಂಗ್ಸ್. ಹೌ ಲಾಂಗ್ ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ ದೋಸ್ ಥಿಂಗ್ಸ್? ಓಕೆನಾ? ಯಾವುದು ಅರ್ಥ ಆಗದಂಗೆ ನೀವು ಸುಮ್ಮನೆ ಮಗ್ ಮಾಡ್ತಾ ಹೋಗ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಬರೆಯೋಕ್ಕಾಗಲ್ಲ. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಅರ್ಥ ಮಾಡ್ಕೊಂಡಾಗ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಈಕ್ವೇಷನ್ಸ್ ಆನ್ ಯುವರ್ ಓನ್ ವೇಸ್. ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಇಷ್ಟೆಲ್ಲ ಎಕ್ಸಸೈಸ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ರೈಟ್? ಆದರೆ ಒನ್ಸ್ ಯು ಗಾಟ್ ದಿಸ್ ಪಾಯಿಂಟ್, ಆಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾನೇನು ಬರ್ದಿಲ್ಲ, ಫಸ್ಟ್ ಒಂದು 2 ಸ್ಟೆಪ್ಪಲ್ಲಿ ಬರ್ದಿಲ್ಲ, ಅದನ್ನು ಬರೆದ್ರೆ ಸಾಕಾಗುತ್ತೆ. ಹಾಗಾಗಿ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ as indirect addition of hydrogen peroxide, water across the double bond. Yes, hydroboration oxidation reaction. ಹಾಗಾದ್ರೆ when unsymmetrical alkene undergoes hydroboration oxidation reaction, then addition across the double bond takes place, and of course you are going to get anti-Marconi Corps product. If direct addition of water happens, there is a Marconi Corps product. ಹೌದಾ? ಹಾಗೆ ಅದಕ್ಕೆ ನಾನು ಹೇಳಿದೆ, when propene reacts with water, direct hydration, 2-propanol is the product. When propene reacts with diborane followed by oxidation with hydrogen peroxide, you are going to get 1-propanol, indirect addition of water. So this is what we call it as hydroboration oxidation reaction. Remaining things in the next class. Thank you. Right.